now to addition reaction. So zote zinakuwa nini? Addition reactions. Now, I was very particular about addition reaction. Addition reaction is only special for the two unsaturated hydrocarbons. Number one, it is special for alkenes and alkynes. Alkanes haifanyi addition reactions. It undergoes what we call substitution. Now we take one hydrogen and then we add another one. I think we'll see later on in examples when we'll be dealing with examples. So number one of the addition reactions. Now, in summary, the addition reaction that is undergone by both alkenes and alkynes, hii yenye tuna study na the immediate predecessor yenye mulifanya before hii. Yes. So hizi ndo zina undergo. Now the main difference between the addition reactions in yenye tuna discuss now, which is alkynes E, na ile yenye muli discuss maybe a week ago, which is alkenes, is actually the speed at which the reaction occurs. Ingine inaoccur faster than the other one. So that is the major difference. The rate at which it occurs, which when I talk about the rate, I'm talking about the speed. Now let us continue. So number one is addition hydrogenation. That is addition of hydrogen, of course. That one is addition of hydrogen. Of course, it is with the presence of nickel. Now, this reaction can occur. That is what I normally tell people. It can occur peke yake. But now the reaction is very, very slow. Too slow. Yeah. So we need a catalyst. Now, remember maneno ya catalyst. The function of a catalyst. Actually, it is only to speed up the rate of reaction or to fasten the rate at which the products are the reactors are consumed, or the rate at which products are produced. That is the only function. Now, if you react with a single mole, it will form ethene. But remember, we have an optimum temperature, which is around 200 degrees Celsius, and of course, presence of a catalyst. Now, if you further, now I will tell you something. Let me just do it again. Let us just check out fast because it has already been written. So I'll write again so that you see. So this one is 1 mole. This one also is 1 mole of hydrogen. If you further continue to add another mole of hydrogen, and then you get ethane. We go back now to the first one. This thing is normally written differently. I don't know if I have enough space so that I can do for you, so that you don't get confused in an example. Ikienda, you don't say you were not told. Now, sometimes we, the teachers, we just want to check if you really know what you're doing. Now, what they normally do is they'll give you something like this. They don't even have to give you the structure, the structure. They can, I don't want to do the structure for the sake of, or let me just do it. I thought for the sake of space. So I'll do it. This one is the structural of alkyne. Alkyne. Now, the process can jump from upper all the way, iruke direct to this one. So you don't have to go all the other processes. This one only is for an example, but you have to understand that I can change that example. Na niseme ikae hivi. Now what I'm saying is I want something, I can put something like this, 2 hydrogen molecules, and then I maintain everything. So we have the nickel. Let me just write in short, catalyst. Yeah, catalyst. And then of course you maintain the temperature. I hope this one is clear. And then now, so I jump directly to this one now. That means I remove all of them, and then now I'll come back to this one. So I'll go directly to this place. I hope that one is okay. iko sawa. So you don't have to use the longer route. Sometimes the questions are tricky, or even sometimes you are not even given. I don't know. Now Abdi is not in. I was supposed to say something, but anyway, I will say. But maybe nitarudia akiingia hiyo maneno ya chart. When you're given that flow chart, I know that is where the problem normally comes in, especially in organic chem, both 1 and 2. Now, when you're given, sometimes unajua hii ndo imeform, and then they don't tell you that it is 2 moles of hydrogen. Wanaweka tu hydrogen in full, eh? So when they write hydrogen, and then you know what is being formed could be ethene, but now kitu imepatikana hapa, and then another reaction that continues, you are very sure yenye iko hapa ni ethane. It is not. So it means again that we have skipped something. We have skipped the process of adding one hydrogen and then another hydrogen. I hope that one is okay. So the most important thing, Upper, the most important things that you're supposed to remember, Upper, actually, is the optimum conditions that favor this reaction, or that allows this reaction to occur. That favors this reaction. Ukumbuke nickel catalyst. We have other catalysts that are very important. Again, that I know you have interacted with, but don't forget what you use here. Now, so the second addition reaction. So we just mentioned the rest, but the second addition reaction is actually halogenation. Now, there is a problem with this halogenation. Now, first of all, you're supposed to know halogenations. We must know the first. We must first of all know the halogens. So you have the fluorine. So unakumbuka hizo chlorine, bromine, and iodine. Although there's normally something that normally inaleta shida na hii. Some of these ones will not react. By the way, it might not react. Some of them. So we normally add something for them to react, or we change the conditions. But we're not going to touch on that one because it will be, I think it is in Form 4. And I'm hopeful that we are beginning Form 4 very soon. So there's no problem. So now, another thing that you're supposed to remember, halogenation now is one of the, what do you call, one of the tests that we use to normally test what you call this, or test on saturation. And to be specific, we are using this one, the bromine. The bromine. Tunatumianga bromine. That is very specific. Now, the reason why bromine is chosen is because of the color. Now, we want to make work easier. We want to make work easier. I don't want to talk a lot about that one now because I'm dealing with something different. But allow me to talk about that one when I open the other slide or the other pages of maneno ya what do you call this now? Practical sessions. Practical. I don't remember that thing, but I know I'll get it. Nitaitafuta tu because I have it somewhere. But I don't remember how I saved the documents. But najua iko. So tutapata. So so ethine actually reacts with red brown bromine vapor to form. Now it follows the same way that you were given. Yeah, hydrogen. So if it is bromine ya kwanza ina form 1,2 dibromo. Ethene, not ethane. But if you had now 2 moles of bromine ina form sasa the tetrabromoethane. And this one actually is normally used somewhere. I don't know if you remember. But it is not the tetrabromo. I think it is tetrachloro. Is used somewhere. Maybe you can go through and then you confirm where it is used. Eh? So it is the same process. I don't know if we are okay. Do I have to repeat the same process? Hiyo yenye nasema sometimes they can set for you ujimalizie, ama I can just continue because I know you can. It is the same way. Now, maybe something I'm supposed to mention before we continue. Anytime you're adding something to the alkyne, you remove the bond, one bond ya katikati. What I mean is this. Let me just show you so that it becomes easy. So these ones are 3, hapa ni 3. So anytime you're adding something new that was not there in the original, you remove something up. So hapa imebaki 2. You continue adding, it was 2. If you add something else, anything, I'm talking about anything, you remove what is in the middle so that it remains 1. I think that one is very important. Any reaction that is taking place between an unsaturated hydrocarbon, you must take out, or you must make it saturated. Take out one of the bonds that is in the middle. Check out that bond that is in the middle. Unless there is a query. Unless there is a query. So everybody is okay. I just wanted to confirm. Hey, Caroline, it has been a while. I don't know if we met with Caroline. It has been a while, eh? I think we met sometimes back. I don't know, or it was a different one, or I've forgotten. So everybody is okay. So actually, these things are normally very easy. The only problem that comes in, the only problems that comes in, actually, we will see. I am hoping that we are going to do an example that has what do you call those charts, so that you see where the problem will come in, and then you'll be answering, and then you'll tell me. I don't know what normally happens, but you will see. Now, there is of course chlorine that has a special case, reacts explosively. That is what I'm saying. Remember, the most important actually to remember in halogenation is the reactivity series of those halogens. As you go down the group, the reactivity of the halogens reduces. That is why the first thing I mentioned when I started halogenation is some halogens do not react with ethyne for a reason. It doesn't react. Otherwise, we must do something for them to react. Otherwise, they do not react. Yeah, because they are very least, like, I don't know if it is correct to say very least reactive, or they do not react at all. They are not reactive, so they're just there. But the rest, that is why now you see chlorine is among the top. Or is it among or between? Among the top of the halogens. So the number 2 out of 4. So that is why it will react. Now, if we were to do fluorine, it will be very explosive. That is actually what I just want. So it reacts to form HCl and carbon. And this one is a very special type of reaction. It is a very special reaction, which people normally forget in an exam. So it is very special. Please do not forget. And they will tell you it is pure chlorine. Now, when it is diluted, of course, in a form sasa ile tetrachloroethane, and there is a use of tetrachloroethane. Hata simuniambie kwanza use of that thing. Do you remember? This one is where the application comes in. Do you remember the use of tetrachloro? Is it tetrachloroethane or methane? But that one, that is what I was saying. Yeah. It normally has another name. I can't remember the other name. No, it is carbon tetrachloride or something. I think it is carbon. From what you write, from what you get, it is tetracarbon. It is normally a very good solvent, actually. It's very good. So these ones is what normally happens. That one is what normally happens. And I'm saying now, before when I continue, the main difference between this reaction na the reaction of the predecessor, ile alkene sasa, alkene, is actually, this one is faster. Hii ni faster kuliko ile. Hii inafanyika haraka. That one is very important. Go and look for the use of, I think it is not tetrachloroethane. I think it is tetrachloromethane because I think I have used this some time back. I think it is tetrachloromethane, but it falls under that group. Now, another addition, hydrohalogenations. Now, hydrohalogenations is a mixture of hydrogen and halogens. So, for example, hydrogen chloride gas. Those ones now, that one is a very good example. Yeah. So, again, just like I mentioned before, ethane does not react with all hydrogen halides, just like it does not react with all halogens. So, it doesn't react with all of them. It will react with others, others will be left out. Now, for example, we have hydrogen halide. So, what is formed actually is the same thing that is formed uko juu, but the only difference is actually the others are hydrogen. For example, let us just do it so that you understand what I'm saying. Huh? Now, you see these ones have given you two of them. Now, if they had given you one, kama wangetoa hii, for example, let me just rub this one. If they remove this one, whatever is formed is not this one. It is actually an ethene. So it is very important for you when you are given a question, especially to write an equation, or you ask what is formed on the other side. Please make sure umeona umepewa ngapi hapa. Check the moles that have been given. If they have given one, you know now the problem is sometimes they might not give you, but if you are given, confirm kwanza kabla ujaandika your answer, because sometimes it can bring problems and it can lead to you losing marks. Yes, so that one is okay. Okay, so that one is at room temperature. I want you to see the difference. The difference is normally very visible, but the students normally, I don't know, they tend to, I don't know if they get confused or they forget. Now, when you have halogens, now I'm giving the difference between halogenation and hydrogenation. Now, the most reactive halogens in the order, let me just write in that order of the most reactive. So, fluorine is the most reactive. Chlorine is the second most reactive. And then we have bromine is the second last. And then we have iodine, which is the least reactive. Hata hii time ingine inakataa kureact peke yake. So lazima uongeze temperature kidogo or you introduce something else inside. I hope that one is okay. Now, when you come to halogens, I want you to see what is happening. Yeah, hydrogen iodide actually, which is the least reactive in the halogens, reacts easily than the one yenye iko juu yake. So unaona ya bromide, hydrogen bromide, we need to what? To warm a little bit. But there is normally that confusion that the students decide because fluorine is most reactive or is the most reactive among the halogens, automatically it becomes the most reactive when it comes to hydrohalogenation, and it is wrong. And the thing that makes it wrong is because now when you introduce something else inside, it is no longer the fluorine that is or the chlorine that is taking care of it. It is something else that has been introduced. Yes, which is the hydrogen. I normally tell my students that way. Always check first of all. There's something. So we must warm for the other one, as you can see. So you warm, and the process is the same. What is only formed, actually, what is formed is a dibromo. Now, before Monica will ask me a question, there's something Monica wants to ask. And before you ask that question, let me answer. Now, I'm very sure. Uh, I want you to see how it has been written here. I want you to see. It doesn't matter where the good thing about this one is it doesn't matter where you put the hydrogen, but it is very important to see. I want you to see when you make one iodine up, an iodine up, hydrogen and hydrogen. I'm assuming those ones are the ones that are coming from the hydrohalogens. Huh? And now to write TV, this one is okay. That one is the first answer that I would expect from you. And it has a reason. Hydrogens are given first priority to take over the carbon. So you cannot say hydrogen moja na iodine moja or the iodide now are taking the first hydrogen, then followed by the second one. So the hydrogens are the most in this case, and they're given first priority. I want you to see this one also. So the hydrogen comes first. And I'm saying it doesn't matter because now we know that we count from either uku ama uku. So it doesn't matter anyway where the hydrogen, but hydrogens inaenda to one carbon, the same carbon, and then you can give now. I'm saying give the priority to the carbon, to the hydrogen. So the first carbon or the least carbon can give the priority. What we do is do not, what can I say? Do not usiweke kando kando. What I'm saying is this. Let me just write so that you see. What I'm saying is do not do this. So and then I put hydrogen here, and then I put I, and then I put. I know this one is very beautiful. Yeah, this one looks very nice. But if you get a very strict marker, very strict, of course, which KCSE, I have never marked chemistry before. I'm not a marker of chemistry. I'm a marker of physics. So I know physics. Um, but I will not recommend that you do this. Now, I know people will ask me. The next question that people will ask is this: why have you said 1-1 die? 1-1. That means this one is hydrogen number 1. Now we go back to what we call substitution reaction. In substitution reaction, after this thing has changed to an alkane, ikishaenda kuwa alkane, everything changes. It is no longer the same. So we give priority now to the branching. We give priority to the. So I think it normally brings confusion, but inaeleweka. I don't know if you have understood what I just mentioned there. Because somebody will ask, why is it 1-1? That means we have given priority to carbon number 1, which have iodine. Now, it was priority when you're reacting because it is another group. That is another family. And then you're introducing somebody else. Now, into the family, when you introduce to the family, you have introduced 5 children. Among the 5, there's one that will be preferred. Now, that one will be anakubalika easily to the family, which is hydrogen. Now, iodine bado anasomwa, anaulizwa we ni nani. That is what is happening. Alafu akubaliwe. Na akishakubaliwa ndani, we go back, it becomes a different family now. You don't call yourself a single family, which was alkynes. You go to a different family, is called now alkanes. And that family of alkanes has different rules. And those rules say the priority is given to the halogens when you are naming. and then you can go and confirm that one. Kila mtu ako sawa hapo, so that I continue. Na bado watu wananisikia, or I'm talking to myself. You know, I get worried when I don't get an answer. Uh, yes. Yeah, okay.
Just proceed.
Yeah, so iko sawa hapo juu moja nilikuwa naogopa utaniuliza hiyo swali.
Iko sawa mwalimu.
Yes. So it becomes okay. Now, what is very important actually is to remember hiyo story nimewambia hapo juu ya halogens. The most reactive halogens is actually fluorine. But when you come down here, you see now chlorine, it reacts slowly with the drain, pole. But chlorine was reacting explosively. Are you seeing what is happening? We have interchanged. And remember, we still follow the same rules. 1,1 dichloro, it becomes okay. But it is very important. Now, hydrogen fluoride in that case, if this one is reacting slowly, so I don't even have to do the testing for hydrogen fluoride. So it is the opposite. Nilisema huko juu kwa halogenations, iodine kidogo is very slow. In this case, hydrogen fluoride also is very slow, hata inakataa. So that is why we don't even do the, but if you are given, please know that it is 1,1 difluoro. Then, yes, if the question is test now for alkynes, so that we do some examples. I don't know if we do an example first or I tell you your combustion. You tell me so that I can know. So I want you to see now because, okay, I think we are supposed to do so that it makes sense what we are talking about. You just tell me. Now, test for alkenes is similar to the test for alkynes. Yeah, where it decolorizes actually the oxidizing agents. The only difference now is gani inafanya haraka na gani inaenda polepole, and we have already talked about that one. Any query?
No query.
I want us.
Yes.
So I wanted to ask if we let me just make a point up there and then you continue. I wanted to ask if
Kwa hapo kwa additional reactions ndio bado sijani. Reactions with hydrogen alafu tena hydrogen halogenation ndio kidogo sijashika mzuri, nilikuwa nimerudi site.
Okay, let me just tell you. When we have three major types of addition reactions. Number one is hydrogenation, which is addition of hydrogen. Yeah, I'm just using layman's term, layman's language. Addition of hydrogen because it is an addition reaction. So hydrogenation, addition reaction. Actually, hydrogenation has a very good use. I think you did that one, Ukoju. I don't know if you still remember. So hydrogenation. That is number one. Number two is what you call halogenation. Now, halogenation is addition of halogens. Na nikasema halogens ni fluorine, chlorine, bromine, and iodine. And in that order, that is the highest. The most reactive is fluorine going down to the least reactive, which was iodine. Now, I came back. Also, we went to another step, which is hydrohalogenation. Hydrohalogens is a combination of an hydrogen and an halogen. So inaitwa hydrohalogens. Iko sawa mpaka hapo? Now, and some of the examples now, that one was the last part. So hydrohalogenation is the addition of hydrogen halides. Hydrogen halides ni kama hydrogen moja na iodine, hydrogen moja na chlorine, hydrogen moja na fluorine, hivyo. That one is what we call. Now, the only problem that comes in actually in hydrogen fluoride, let me show you what normally happens. That is why it is not tested hata hapa. Most of the time we don't test hydrogen fluoride. Let me just write for you the chemical formula for hydrogen fluoride. Inakuwa hivi. Inakuwa hivyo. And this one is something that we are going to do in electrochemistry. It will be explained in electrochemistry. Don't ask now, because if you ask now, you could get confused. So I will explain this one in electrochemistry. Hopefully this time, I'm very sure we'll meet it in this time. So that you see, that is why actually sijaweka hapa chini, or it has not been placed there. But it is very easy. Or we normally say it doesn't even react. But hydrogen fluoride is written that way. Aya. Abdi imekuwa heri. But when we be doing examples, I think it would be easy. You can easily understand. And because I want to do ile kitu yenye ulikuwa unasema inawasumbua Abdi. You say the chart inawasumbua. So we are going to do actually a chart. Now, my question is this. Do we do some example first, or we go to that practical session so that we can come back and do the example, or ama tumalizie hiyo baadaye, because it is something that I already tulifunzana sometimes back, but I know most of you are not in. I can remember the people who are in and those who are not. So which do we do? Do we do examples? Because
Yes,
actually
ma'am.
that test, yes, that test of it is the same. It is the same. So let us see. I don't know if this one has answers. If it has answers, I'll have to go to another one, because there's something I wanted to give you. I think this one has answers. Now let us do this exam. Can we do this exam? Do I leave you to try? I give you like 10 minutes. Yani usisonge hata. Yeah, let me check. Somebody has written something. Yeah, we are doing the example. Can I give you a few minutes to try this one? But this one is actually the immediate one that we had. We did, of course, except the first one, which was done previously. What do you think? Can I give you maybe, at most, actually, I'll give you 5 minutes. And then we discuss so that you understand. What do you think?
Teacher, are we doing the nini? Tunafanya hiyo.
I can, because this one now I can't give you, because I've seen that the teacher wrote the answers actually. So for
Okay.
example, but the most important thing, now let me just explain this one, and then we go now to an actual example that has not been answered. Because now, the most important in this one is to understand each and every step. I want you to say, step one, unajua, you are supposed to remember. In step one, you're supposed to remember preparation of those gases. But that one actually is not very important. You are supposed to remember the use of sulfuric acid. And we know that the use of sulfuric acid is actually to remove. It is normally used concentrated actually. It is the L, simeandikwa L. Naona hii. Ikiandikwa L, let me just tell people so that they never forget. When an acid is written as liquid, it is concentrated. If it is written, if this one now was written as AQ, that one is dilute. Because but this one they have written as aqueous, means dilute. When it is in liters, or they have given you R, liquid now, liquid form. That one is concentrated. So that is dehydration process. You go to one of the gases was prepared by dehydration. Actually, it is ethene. And then when you eat with oxygen, it normally leads to formation. So the good thing about ethene, and ethine, yote in a lead to formation of the same thing. So in a lead to formation of CO2 and water. If you can identify everything that way, and then step number 3, you have adding an hydrogen chloride. That is, we are doing what you call hydrohalogenation. Sindio? And then from that
Yes.
gas again, we add in step 2, where we have nickel catalyst, and then we have inakuwa ethane, that is hydrogenation or umeongeza hydrogen. So let us see now. So if you understand, you can answer all the questions here without even going to, before even you reach the answer sheet. So ikuwe rahisi, unajibu tu. So let me wrap this one so that I can come back to this one. And then I can show you the summary. I have a summary. I think the summary is in the top notch, which we'll open and then we see. So name colorless gas A. You have that one, ethene. And then the equation has been written. Now, something that I almost forgot. It is very important for you to know how to write the equation. Just in case Kiumane, because the next question, my next question actually will be write the equation for the formation of the above. A, B, D, evil, which could be risky if you don't remember. So product here, B, where is B? I'm not seeing B. So here, so when you add ethene to HCl, you see they have given one. It was very, so it equals chloroethane. That one is okay. Gas D, CO2. Now, there's something I want to talk about gas D. Let me just ask you, because I know you are aware of this one. What is this? What do we use to taste carbon dioxide? Chemical taste for carbon dioxide. No, you're answering that one. I'm waiting for you to answer.
Teacher, carbon test, I mean, you said the question is?
Chemical taste. Chemical taste for carbon dioxide. Chemical taste for this. Let me just circle. That it becomes easy. What is the chemical taste for this one? Because sometimes they will ask you, what is the chemical taste for that one?
Lime water.
Calcium.
What about lime water? Because you must say something about lime water.
Calcium oxide.
Calcium oxide is lime water? No. No. But it is calcium something. What I'm asking is, somebody said
Calcium
calcium.
hydroxide.
Yes. Now, what about it? Is it a, what do we do with it and what is formed?
It forms a white precipitate.
Yes, that one is actually what I wanted. So you say when you bubble through calcium hydroxide, it forms a white precipitate. That one is actually the chemical test for carbon dioxide. Now, there was a student who wrote for me. Now, let me give you these answers so that you can confirm kama ni right hata nyinyi. What if we say it extinguishes the burning splint? You check if it is correct. Don't answer now. Mutaniambia baadaye. Now, liquid E. So the good thing about when you heat, this one is combustion, in combustion actually. The good thing about combustion in organic chem, in organic chem 1 is the products. Products zote zinafanana. I don't know if it is making sense. All the products that when you burn ethane or ethine, or you burn ethine, the product will be Maura. Tell Maura to mute.
Okay.
Yeah. Please mute. Yeah. Okay. So I'm saying in combustion, when we burn ethane and ethine, the product, the gas D is CO2, kwa yote. unless of course they are say limited, which is very rare cases. And then liquid E kwa yote water inachomeka to form CO2 and water. And actually, this one is not what we call neutralization reaction, because CO2 is gas. Now, and then now goes question, those are doing revision. Anyway, sometimes I will ask a tricky question now after this. What is the chemical test for water? So we are revising. I just wanted to touch, because it is a possible question that could come. Chemical test for water. And you're answering that one. Chemical test for water. I've mentioned that one severally. Actually, upper in this class. I've mentioned it severally. As you think about it, but I need the answer.
Cobalt.
Chemical.
Cobalt to chloride. Cobalt.
That is not the
to
answer.
chloride.
Tell me now, what is the color changes? You tell me the color changes. It changes from this to this, because that is what I am interested in.
Changes from pink to blue.
Are you sure? When you add or when you remove?
When you remove, but when you add, it changes from.
Yes, that one is a very
from
important statement. Unaona sasa shida. If you tell me it changes from blue to pink, you are right. Mtu mwingine akisema it changes from pink to blue, both of you are right, but you didn't give me where we are starting. Sindio?
yeah.
So that one is very important. Another one, we have two major tests of water. Chemical test. Not the, don't tell me boiling point and melting point. You don't tell me the pH. Which other one should not be mentioned? I think those are the two that most students normally mention. Wanasemanga,
Copper sulfate.
yeah, copper 2 sulfates. So also it changes from, when you add water, when you heat it will change from blue to white. And vice versa. So if it was white, na uongeze maji, inakuwa blue. Ukihit, inaenda the other way around. Those are very important things that you're supposed to know. And it's actually coming in another class. Actually, it's not this class. So write a balanced equation for the reaction forming product A. You see now the next question. Yeah, I wasn't even aware that the questions that were coming next were right. That is the problem now. Imagine unajua answers, lakini hujui kuandika nini? The
Teacher.
equations. Yes?
Teacher. Now,
Yes.
what about this? If we talk about the litmus, it has no effect on litmus paper. Is it also a chemical test?
No,
Ama?
that is what I said. That one is wrong.
Yeah. It's a
Question
property.
answer number. No, we are, water is neutral. Now let me ask you something. What do you know about salt? Ya nyumbani.
Sorry?
What do you know about salt? Chumvi ya nyumbani.
Oh, it dissolves in water, ama?
Is it neutral? No, is it neutral or basic or acidic?
It's acidic.
Salt. Somebody told you salt is acidic, because I never mentioned that. And I mentioned that one again. There was a time we were dealing with salts in Sinimindo nilifunza salts. I think I did the introduction part.
Yeah, it's a basic.
Is it basic or neutral? Salt ya nyumbani ukikula iko na effect kwa tumbo, inaleta shida kwa tumbo. I don't know.
Haina.
Yes, so salt is actually neutral.
Yeah.
Now, how do I know nikitumia litmus paper that it is water or it is sodium chloride that has been dissolved? Because both of them will be neutral, basically. That is why we do not use. What I'm saying is, a property of water, it is neutral in nature. Now, we have a lot of other compounds that are neutral when they are dissolved in water. So ukitumia hiyo test ya kusema ya affect litmus paper, you could be drinking even poison that is neutral. But now if there is another element in water, now for example, if I react dilute sodium chloride na copper 2 sulfate, the reaction will entirely be something different. Sina ukweli? So nini kama ile story yenye wanasema I know there is a question that normally brings confusion, especially the form 4. Wanaulizwa uses of oxygen. We know that oxygen is used for germination. It is used for by plants to germinate, alafu inatupea. Is it used? What is being used? I know some oxygen is being used by plants. I didn't take biology, but I know oxygen is used somewhere. Is it using carbon dioxide that it produces oxygen? But there's a place where it is being used. And then you cannot say again, oxygen is used for breathing. So we are breathing in oxygen. But do we say it is used? We are using it. Is it correct to say it is used for breathing? In an exam? Industrial uses of? Yeah. So it is the same thing now with your litmus paper. That is why the first wrong answer of chemical test for water is neutral. It doesn't affect litmus paper. The second wrong answer is boiling and melting point. Now, the reason why we normally say it is wrong to use melting and boiling points, we have very many things that actually boils at 100 degrees. It is not only water.
Teacher, those are physical, but isn't it properties? But those are
properties. But they are physical.
Yeah,
those are physical properties.
Okay.
But remember what the question has been asked. They're saying the chemical, industrial. Now, there's something that normally brings confusion. What wakiulizwa in most of the time, there is no difference between industrial properties or industrial usage and the chemical usage. Zinatembea pamoja hivi. That okay? Yes. Okay. So right balance equations, there's no problem. We had already written. You can confirm with your in your other, because I know this one was already written. Yenye tumefanya hata sahi ni ya second. The second one where we have the ethene being the hydrogenation, being added with hydrogen halide in a form. Nikiona tu iko na 6, unajua ni ethane, chloroethane. And then the other one is combustion. Here chini ni combustion. And we did that one. CO2 and water. Please, this one is not balanced. All of them are not balanced. Make sure that you balance. Name the reactions, very important also. To say it is dehydration, hydrogenation, we had already mentioned. Say the importance of the reaction taking place in step 2. Hydrogenation. Mnakumbuka nikisema hydrogenation is very important. Now, it is normally used in hardening of oils to fats. And then, of course, manufacture of the blue band. Margarine is normally the blue band. I don't know. I want to do another. There's another question that I want to do. Can I move from this one so that we go to something else?
Yes.
Yeah, let me just open another book. I hope nilikuwa nimeipata very quickly. Yeah. But now the good thing about Top Notch, yeah, let me check if it is opening the correct page. Thank God it has. So, and then we do now another example. But now that topic is done. We are done with that topic. So I hope you have understood something. I don't know if it is visible. Now the only person that I'm worried about visibility is actually Abdi. Now let me talk about the test for unsaturation because we didn't mention it on the other side. Test for unsaturation. We normally use bromine water or acidified potassium manganate 7, which are now we call them oxidizing agents. So we tulisema ina decolorize. That was number one. In a decolorize. Now the only problem is knowing the color. Bromine water is normally yellow when it has what do you call it? When it has impurities. But if you can say orange, mara mingi ya za mashule mingi. Actually, the other, if you are given bromine water in your KCSE, most probably it will be orange, red, brown, that one, orange or yellow, depending, but it will change to colorless. It is here. That is this one. Talk about this. That is one of the tastes, and this one is also used to taste what? Hii pia inatumika kutaste sio alkynes peke yake, pia alkenes, and they are the same things that have they have common changes or common effects on this thing. Zinafanana, alkynes and alkenes, that one. Now also potassium manganate 7 changes from purple to colorless. There is one that is special, potassium dichromate. Potassium dichromate normally changes color. It is not changing from purple to colorless or something. It is changing from something else. Potassium dichromate is also an oxidizer. It changes from orange to green. But the major ones is manganate 7, which is changing from purple to. Now ukipewa hii, these ones are very easy. But also even after ile dichromate is very easy. So another test that is similar between alkenes and alkynes ni this one. You see this one? Sorry. Burned with a yellow sooty flame. It cuts across. Zote mbili zinachomeka na sooty flame. So don't forget those ones. Oxyacetylene flame. If you remember hizo vitu, uses of alkynes, I think we did mention that one. I think we can mention maybe 2, 3. It is very important for you to remember at least 2 of these. Manufacture of synthetic fibers, adhesive in production of solvents. You remember sasa ile kitu tulikuwa naongelea tetrachloroethane. It is a very good solvent. Very good. Actually very good. Kuna ile organic and inorganic solvent. Hii ndo moja. That one. Manufacture of chloromethane, which is used normally to manufacture PVC. PVC, let me just give a very good example of a PVC. Kila mtu hapa wako na stima, or if you don't have stima, you have used water from the kisima, from somewhere. Hiyo pipe ya black, let me just give a very good example. Hiyo pipe ya black, hata ukiangalia kwa nyumba sahii lazima kuna pipe ya black iliwekwa ikipitishwa waya stima to the socket or somewhere. That one is a PVC, which is very important, actually very important. I know the others are not people, but synthetic fiber also is very important. Plastics, very important. And then I was talking, I think before I came to kuja to use it, I was talking about oxyacetylene flame. Ile ya form 1, mnakumbuka uses of oxygen. One of them was it is mixed with acetylene and then it is used in welding. That one now is an alkyne. That one is an alkyne. Summary, yeah, I normally love this summary. The person I wanted this summary for, I don't know if I should zoom out ndo kila mtu aone. Can I zoom out? Let me zoom out. I want the whole thing, Yeah. I wanted something like this, Now, is it visible still? Kila mtu anaiona, Now, the only problem that I
mtu
have with
anaweza
this one, yes,
nasema ni visible na mtu anaweza zoom kabisa on his or her side.
yeah. The reason why I'm doing that one is I wanted to, so that we can see. Now, this diagram is summarizing all the things that you did or that we did from organic. One, that is immediately I'll introduce organic one, and the first one ikakuwa alkanes. Iko hapo. All the way. I want you to see. We have reaction 8, reaction 1, reaction 1, 2, 3. I want you to see where it is starting all of these processes. So that usisahau. So we have reaction 1, it has a name. We have, this one is a very good one if you want to remember. I don't know what you will do, but I will share this book again. I know I shared previously, but I'll still share. This one is a summary of everything. The only thing that could be missing out in this one, actually, the only thing that is missing out is the conditions that could have been left out. Iko sawa? So hii ni summary ya yote. But now I cannot teach that one slowly because if I teach, we'll be starting pole pole. We can end up completing at around 10:30 because I have to explain each one. Now, that summary now, ndio hizi. It is that one. You see, each reaction has been given. Munaona sasa? Are you seeing what is going on?
Yes.
Yeah. So the summary, that summary in diagram form has been given the answers. The name of that thing that is taking place, yeah, the reagent that is needed for that thing to take place or for that process to take place, and the conditions that will favor that reaction. So I don't know what you are going to do about that one, but it gives the summary. So niko sasa kwako Abdi. So in fact, let me just share. I don't even remember the group that I'm in. The group that we are all in, so that I can share it now. Registered PCC,
Teacher.
sindio? Yes.
Yes, teacher. Kuna vile
Yes,
unaweza
I'm
share tu
listening.
hizo notes.
Yes,
Yeah,
I'm
kuna
doing
venye
that
unaweza tu
right
share hizo.
away. The only
Teacher,
problem
not
with this
that
one,
whole book.
you don't want the whole book.
Yeah, as in
I don't know.
kutafuta hiyo page huwa
Let me
inaanza.
try. Let me try. The only problem with
Then
this one now, let me
bado you
check
can
if it
hiyo
is
topic
possible.
tu yenye you can
The
still
only
resend the
problem,
book.
yeah, I'm sending.
Yeah.
I've already sent. I think the book is coming. Is on its way.
Mhm.
I don't know if that one is okay. If you can screenshot, you can. I'm trying to check with my phone to see if it is going to work.
I'm a screenshot on
Yeah, you can screenshot, but I'll still share with
yeah.
mine. I don't know. Check if that
Okay.
one is working.
But
I've sent something. But now I've
okay.
zoomed out. So that one is the summary of all the reactions that actually occur. And those are the reactions that will occur with their conditions. Sijui kama watu wamepata, nimetuma kitabu. As I sent the book also, I had promised to share now. I'm going to share, some questions? Organic. I don't know. I hope it is not involving does not involve the form. Yeah, it is the form 4 work. So I've shared again some questions. You can try them. So if you can remember, what I'm interested in, if you can remember all this, you are good to go. So unless there's a query, I want to ask to do one example, and then I'm looking for the other so that I know the name. There was, I don't know, I think I shared. I can't remember. Let me just check if I can't. I'm using my phone. I'm confirming from the phone, so that we can do an example. Practical. Yeah. I think I got it. I think it was called Chemistry Practical Guide. So we will do that one after. I just wanted to know the name. So you iko sawa? Can I bring it back now? Iko sawa? Now let us do one example. I think we can finish even earlier today because we are through. But I've given you some assignment. Please make sure that you go through. Everybody is okay?
Yes, we can see.
Yes.
Let us, we can do. Let us do maybe a question or two. I wanted a longer one. This one is very short, but it is very important.
Uh,
Everything that is done is very important.
yes, ma'am.
Yes.
Kabla hatujafanya example ingekuwa mzuri tu discuss kwanza ile ya Saidi sasa.
Yes. Unasema
Ile
aje?
umetuma sasa ile flowchart.
Ehe.
Ile ilikuwa na answers reagents na conditions.
Oh, you want us to
Kumbe
to go through it? We can go through it. There's no
yes.
problem. But I was just sharing. But the only problem
Yes.
is I cannot see. I have to zoom out the farthest. So for example, let us see reaction one. I want you to see reaction one. I'll show you reaction one. Now the good thing about what we are going to do, this one is reaction one. We are changing ethene to ethane. Now what is that process? What are we doing? Ethene, remember, inakaa hivi. Hydrogen. So actually ukishapewa answers, you can even do when you have the answer, I don't know, when you have ethene and ethane, I don't know, there's few reaction. I think it is easy. Now this one is ethene. Let me just do that one. I can only do that one because the good thing about the example that we're going to do now, Abdi inaguzia ni the same. Hizi vitu yote yenye tunafanya zinafanya hizi, all examples are the same. Hii imesummarize tu zote. Now reaction one. So and then we have ethane yenye inakaa hivi. So hivi 1 2 3 1 2 3. So this one is ethane. So what has happened? Wewe unaona kama nini imeongezwa hapa? It was 4 hydrogens na ikakuwa 6 hydrogen. So what has been added?
Hydrogen.
Now, what is the process of adding hydrogen?
Hydrogenation.
Hivyo tu. Now you can continue reaction 2. Where is reaction 2? I'm looking for reaction 2. Now we have reaction 2 is actually preparation. I want you to see reaction 2 is coming from ethanol to give us ethene. So reaction 2 si ni ile yenye tumefanya tu hapo juu, C2H5 OH, and then ukiweka hivi unaweka concentrated H2SO4, which is dehydration process. This one is dehydration process. Now, so let me move it. Let me check if it is movable. So you see now the process. Reaction one in nini? hydrogen, reagent ni hydrogen, but the process is what we call hydrogenation. And then we have kumbe tu kuandika hata the conditions. Tulikuwa tumesema nickel. Sometimes they use palladium. Palladium is very expensive. So, but it is good to know. And then you have the about 200 because it is 150 to 250. So we normally say about. Now, reaction 2, dehydration, concentrated sulfuric acid.
Mhm.
Temperature is about 170 degrees Celsius or 160 to 170. Abdi huko sawa. So what I was saying, your processes, the processes that are here, the answers have been given. Iko sawa. So that is why I didn't want to do the same. For example, process 1, where we have ethene. Let me wrap that one so that it becomes easy. What do you call this process of making ethene? Have very many things. If that is process 1, I'm talking about process 1. Let me show you the process that I'm talking. It is process. Your process inaitwa aje? Where you have one ethene and then we have very many ethenes connected together.
Polymerization.
That is the process. What is this one?
Hmm?
Hii ni nini yenye iko hapa juu
Monomer.
hii?
A monomer.
Yes, that is now. So mnaona sasa mnajua. Now let us check if it is true what she's saying. So I come back to my settings. That one was process. Process 1, which is polymerization. Now polymerization, what are the reagents? We only need ethene molecules, many ethenes coming together. So one monomer plus another monomer. We don't call it now what do you call dinomer or something. We
Dimonomer.
call them now polymer. Those was polymerization.
Or
We have addition reaction. I want you to see we have addition. Let us go even to 7. Which just jumping. Eh? Of course, it is high pressure and temperature for polymers. Actually, normally used to kuunda polythene, polyethene. So I was saying we go to which one? Any other. I have to rub because of that one. So are you understanding now? Abdi, uko sawa?
Yes.
Yes. So I'm saying the one that I shared is a summary of all the reactions that you expect in organic chemistry ngapi? 1. Iko sawa. So I wanted us to do an example. Let us just do one example. Allow me to do one example because I wanted to share the other thing that we used to taste. Yeah, taste. Yeah, I really want us to know that one. Yeah, taste. So that we can end there for today. So that one is okay. Ama tumemaliza mapema. You know, sometimes, but I want you to try those questions. So let us go to. So I said the book I have shared. The book is very good actually. It has a lot of examples. I don't know. So I don't know. Can we do this one? We can even do this one. That is okay. What I'm interested. You don't know the good thing about this organic chem. The good thing about organic chem, number one, most of the reactions are the same. Most of the reactions that are the same. Huh? Most of the reactions are the same. Most of the reactions are the same. So with the you don't get lost. You don't get lost. Yeah, somebody is. I can hear what they are saying. Yeah, tuko sawa?
Yes.
Yes.
Yes. Okay. Yeah, I could hear some noise background. Okay, let us say, now we have used the flowcharts below to answer the questions that follows. So nilisema hata sio lazima, mnakumbuka nikisema sio lazima hata ukuje kwa maswali, you can answer all the questions there. Everything. You can answer all the questions here. For example, let us start. Now, I normally advise students this way. Follow the arrow. Unaona pale arrow inaanzia. Now, for example, in this case, yeah. Unaona yote inaanzia hapa. Know what that is first of all. If you can identify what that is, you're good to go. Now, for example, uniambie hiyo ni nini?
Ethene.
Yeah? Ethene.
Ethene.
Yes. So this one is ethene.
Yes.
You remember there is a reason why I gave you. There's a reason why I gave you the summary in all of them. There's a reason. Now, okay. Wacha tuanze. Wacha tujibu tu. Do we answer it the questions ama tufanyie hapo kwanza?
Tufanyie hapa kwanza teacher.
Gani hapo?
Si tufanye hapa, si ndio? Now, I'll be
Yes.
changing the color. Let us talk about this process where it goes to this place. Which process actually kwa ile vitu nimetuma requires nickel catalyst, and remember it is forming, what is this?
Ethene.
Ethene, si ndio? So
Yes.
which process requires a nickel catalyst or a palladium catalyst ndio iform ethene? Hii ni process gani?
Hydrogenation.
Yes. So hydrogenation. Kila mtu ako sawa?
Yes.
So I'm still advising you and saying, when you see this thing anzia pali, a arrow, go to the middle.
Imeanza.
Now I'm changing the color so that we go upwards. So there's a place where when we hit this thing, when we hit the ethene, it normally forms water. Na nini? This one is water. Na nini inafomiwa ingine?
CO2. Carbon
CO2,
dioxide.
Carbon dioxide. Kila mtu ako sawa, kila mtu anafuata hii story, si ndio? So that it
Yes.
becomes
Yes.
easy. When we're answering the questions, I'm changing the color again. We come to the second one. Hapa. Yes? We are starting from ethene. And then what are we doing? What have we added?
adding
What is this?
halogen.
We are
Halogen.
adding
What is the process of adding an halogen?
Hydrogenation.
What?
Hydrohalogenation.
Confirm. Don't be. What is the process of adding an halogen?
Teacher, halogenation.
Oh,
It is halogenation.
We are not having
Yes, I know. Now that is unaona sasa. So it is halogenation.
Teacher, inakuwa hydrohalogenation where we have water.
No, inakuwa when we have
adding
hydrogen. Now, for example, you know this one, the answer is guiding us. Now, let me explain that one. Can I explain using writing? Let me write so that you can understand. I'm going to write it. I hope itakubali kuandika hapa. So our answer is saying it is C. I want you to see now. Ni H2 na Br, si ndio?
Yes.
Alafu ingine ni C.
Oh.
Alafu 1. Si ni H2 tu kwa each one na Br.
Yes.
So what has been added? Vitu zimeadiwa ni
Halogens.
E
Ni halogens.
na E. So ni halogen.
Okay.
Now, if the answer of this one had been something like this, unajua tukipata answer tofauti. ungepata kitu kama hii Mwaula. Let me just write. I hope everybody can see this one. HH and H, and then I put another one na niweke sasa hivi BR, and I put H and H, which now the answer could have been CH3, CH2, BR. Ingekuwa hiyo yako. So you check the answer. Iko sawa?
Iko sawa.
Ingekuwa
Lakini
sawa, si ndio?
si ni same tu yote mwalimu.
These things are not the same.
Si hapo iko na bromine moja na hiyo ingine iko na moja tu.
Mimi naona mbili. Nani mwingine anaona moja?
Mbili.
Wewe umeweka wapi ingine Abdi? Now let me leave that answer so that you see. Now, Abdi, you are saying unaona moja. Zote ni zinafanana. Now, how many bromines are here? How many bromines are there? Ile yenye nimesako sahi.
Moja.
How many bromines are here?
1.
2.
Between.
Yes. So
Between
zinafanana hizo vitu mbili.
Hiyo ni 2 na hii ni moja.
So zinafanana?
No.
Exactly. So the other one, ungepata hiyo answer yenye nimerab sasa. Hiyo, what do we call that one? We call that one hydrohalogenation. Lakini juu tumepata ya halogens peke yake ni halogenation.
Halogenation.
Ile iko na
Yes,
moja ndio
I want
hydrogen halogenation.
ikiwa na moja ni hydro. Ikiwa na mbili ndio sasa ina. Now, actually we have not so that one is okay. Now, what is the condition for this process? What is the condition for halogenation? Na tulikuwa tumeona, si tulisema huko. What is the condition for halogenation?
UV light.
Yes, so tunaandika tu hapa. So you should know UV light. Iko sawa. Is the condition. Now, process number 2. We have another thing. So hatujamaliza. We have another process what we call T that is coming down. Hiyo ni process gani? We have an ethene, alafu wameweka a monomer with an N. What do you call that process?
That's
process. Polymerization, si ndio? Polymerization. Now, what is the condition for polymerization?
Ethane molecules.
No, condition. Unajua kuna tofauti ya condition na reagent. So reagent, actually that one is okay. It is ethene. So we have heating. You can say heating, that one is okay. It is temperature. High temperature. Or you can say heating because it is the same. High temperature, or you can say high pressure. Sindio? Confirm.
Yes. Yes. Conditions.
The conditions that are necessary. Now, for example, hii ingine ya blue ya process J. So you have process J. Process J, tuliandika tu ni hydrogenation. And the condition for hydrogenation ni nini? Nickel catalyst. So I just wanted us to write the condition so that we don't forget. Now, have we answered all those questions?
Yes.
The only question that actually you have not answered, I think, is what is the observation that will be made in process K? I think that one is the only one.
Where is K, teacher?
Process K ni halogenation. So I'm rubbing. Let me just rub. You inatuchafulia. I just wanted us to mention so that we see now. Where is K? Halogenation. Is it halogenation?
Yes.
Now, what
Halogenation.
is that thing that you will see? Apple. This one is actually the test for
After
the double and the triple bond. Yeah. So what is the observation? What will you observe? It is very easy. Actually, very easy.
Yellow soot. Production of yellow soot. Yellow
Yellow
soot
soot.
flame.
That's a good trial. But we are not hitting. Process K. Have you identified process K first?
it is
Yeah.
halogenation.
Yes, halogenation. What observation do you think will be visible? It is one of the tests, actually, but very specific. Yes?
Teacher, I've
Yes.
talked about the
Alright.
presence of double bond.
Kutakuwa of na color
Color ya nini?
ya bromine.
Yes. Yeah, actually, mbona unaogopa kusema? Mbona unasema polepole? The correct answer is actually ujiamini. Hiyo ndio shida sasa. So, bromine is normal. Si unakumbuka ikisema bromine is yellow, orange, red, brown. Itakuwa decolorized. That is the test for this one. Mnaona sasa venye hii questions zinawasumbua.
Yeah.
Yeah, so bromine will be decolorized. So that is actually the observation. The brown color will disappear. And then there will be formation of colorless gas, which is now the dibromo. Yeah? Ethane, which is colorless actually. Is it making sense?
Yes, teacher, repeat the answer.
No, the color, the bromine will, sema tu bromine becomes decolorized. It is like saying, kama tungeweka hapo potassium manganate 7 na waseme what would have happened. That again tungesema the observation that would have taken place, the decolorization of bromine. Decolorization now of that manganate 7. That is the observation. Observation ni kitu unaona. You cannot see something that it has no color. Now, I normally tell students, why do you think we see? Macho inatumia nini ndio uone, by the way?
Islands.
Okay. Islands. Na islands inategemea nini?
What you see. Ile kitu.
Head.
Yeah.
Inatumia our mind.
Yeah, but we rely on light. Tunategemea light. For example, stima zikipotea saa hii, we utajua huyu mtu ni mweusi ama ni brown kweli, ama amevaa white or blue. So we use light, yeah. So light guides us so that you can get this color, that color, blah 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 blah. Name another condition necessary for the process K to take place. We have already mentioned that. Tulisema ni
UV lights, sunlight.
okay. Yes, sunlight, UV light,
yes,
any of those. Let us just answer all the questions of that one. Give the name of substance U. That is now the problem of revising. Substance U tulikuwa tumesema ni nini?
Carbon dioxide.
Carbon dioxide. So that is now how you do this kind of question. I have shared this book, but I still think I'm going to screenshot. I'm looking for another thing. Ndio hii ingine tena. Study the flowchart below. Now, these are not giving you directions. They're not giving you directions. But it is good also they're not giving you direction. So nilisema kitu ya kwanza yenye unafanya, but they have, kumbe imewekwa, it's just not very visible because it was scanned. The first thing that you are supposed to uone pahali arrow zinatoka wapi? Hapa. Now what is this? You identify what that is. It is it ethyne or
That's
ethene?
ethyne.
Yeah. So inaanzia ethyne. Now you just check what is that process where you add hydrogens, ilikuwa moja moja ukaongeza ikakuwa tatu tatu, hiyo ni inaitwa aje? Hydrogens ilikuwa moja moja na ile side ingine hapa imekuwa tatu tatu, so what is this?
Hydrogenation.
Hydrogenation.
Ethene.
Na
Ethene.
ini
Hiyo ni C2H6.
yeah, C2H6 is
Polymerization.
what are you saying? Ngoja kwanza, mumeni confuse hata mimi. Hiyo ni polymerization yenye. Now I told you can count these things literally, ile literally kabisa. You say
Hydrogen.
yes, unahesabu kama hydrogen ilikuwa moja na imekuwa tatu, sasa ni hivyo. Now this one ya kwenda juu, ya kwenda hii side, step 1 where you are making it from 1, it was 1 hydrogen. I want you to see, na ikakuwa 2.
Halogenation.
Ngoja,
sorry.
wapi halogen?
Hydrogenation.
Mbona watu wamechanganyikiwa? Is it
Hydrogenation.
what is happening? So nimesema unahesabu hydrogen moja hapo na imekuwa 2. This one is 1 and it has become 3. That one is hydrogenation. Now check this step 2. I want you to check step 2.
Halogenation.
Huh? How many hydrogens were here? 1. Na hapa ikabaki nini? 1. Hapa ilikuwa 1 na ikabaki 1. What has been added? Ni hizi.
Halogen.
Halogen.
So hiyo ni process.
Halogenation.
Step 2 ni exact. That is how you do this one. I'm looking for somebody. Abdi, iko namna gani hii kitu?
Iko sawa kidogo.
Iko sawa, but it is very easy. Actually you count the things. Unaona kitu yenye ni mpya yenye imewekwa hapo. Now let us go to this one so that you see what I was talking about. I want you to see this one. Yeah, let us come to this one. Hii imeteremuka. Ilikuwa na hydrogen moja na hydrogen moja. Hapa iko na hydrogen moja na moja. What has been introduced?
Halogenation.
But it is a double what? Halogen. Sindio? Yes.
Yes.
Now check this one. What is this?
An acid.
Step what?
No, it doesn't have step. Let us wacha sisi tuweke iko step wacha tuweke iko step 6. Ngoja uniambie, we Monica niambie tu acid. Na mimi sijaongelea acid hata. Acid nimesema tu ni HCl what do you call sulfuric acid
No, but nimesema tu ni acid, yeah. Nimesema tu HCl ni acid. So I was thinking bado nilikuwa naendelea kufikiria.
Think.
Na hii ya chini hapo chini.
Which one? No, there's something I'm dealing with first. I'm dealing with the question number, is it step 6, where we are producing A. I'm saying, what is that HCl?
Hydrogen halide.
Yes, that's what, yeah. So hiyo ni process gani?
Hydrohalogenation.
Yes, lakini sio acid, sio. Yes. Mnaona sasa venye hii kitu inafanywa. So what will be formed here is chloro. Of course, it will be chloroethene because it is only one. Now, we have another process where we are burning with, we have excess oxygen. They have not even told you that it is combustion. Lakini ukiona pale kuna oxygen ni nini? Combustion. So it is forming water and B. What is B?
CO2.
Unaona kitu inaendelea. Now, let us step 5. What do you think step 5 is?
What is step 5?
Compassion.
Hydro.
Let me rub this one. Let me rub so that it becomes easy. So that everybody can see what is happening.
Oh, step 2.
Now, before we go to that one, I want us to do step 4. We have a step where we have 300 degrees, 6 atmospheres, and then it forms C.
That is polymerization.
Yes. Hivyo sasa. Somebody is saying something? Now, I want step 5.
Hydrohalogenation. We have hydroxide na halogen.
Kuna
You know, this one is not, I didn't teach you this one actually.
na kuna OH
I did
mwalimu,
teach you that one.
hiyo
Huh?
kuna OH.
What is OH actually?
That's alcohol,
Huh?
not alcohol. The hydroxide.
Yes.
So what is happening there?
Teacher, we also have an halogen. Halogen iko hapo
We have
pia.
an halogen.
Yeah. Sasa itakuwa hydrohalogenation.
No, that one is not hydro. You know, when you talk about hydrohalogenation, we are talking about hydrogen. Now, let me explain it this way. Umeelewa kitu nataka kukwambia?
No.
I'm talking about
Just
something
say
like this. But now, these have added what?
OH.
Bromine and OH. Yeah? This one you did it in the other, you did it in alkenes. I know people have forgotten this one. When you had an alkene, when you had bromine water, bromine water. Now let me ask you, what is bromine water? We said it is an oxidizing agent, yeah? So the observation that you expected here actually is decolorization in your bromine water. Bromine water, not bromine. You know this one is a bromine gas.
Yeah.
This two, eh? So this one is bromine water. So you
Water.
expect the decolorization. This one actually is very common, eh? It's very common in the practical sessions, but they will not ask you to write this thing. Of course, they will not ask you to write that one, but they will tell you to give the observation. Iko sawa?
Yes.
I know that one
Yeah,
has.
the process.
So this one is hydroxyl. Eh? This one is reaction with the bromine water. This one is oxidation process. Normally reaction with oxidizing agent. Bromine water is an oxidized. So this one is inakuonyesha iko na nini? Hydroxyl is from water. Yes. Now we are there. This one comes from. This one actually, I wasn't. Yes.
Step 5.
Oxidation. It's normally oxidation process. It's normally an oxidation process. Yeah. The one that you are reacting with bromine, you are reacting with potassium manganate 7, potassium dichromate is normally an oxidizing process. Huh?
Teacher,
Yes, yes.
apart from hiyo bromine, tunaweza letewa nini kwa hiyo oxidation apart from bromine?
They
Wanaweza
normally give you, yeah, that is what I'm saying. They normally give you what you call potassium manganate 7 or what you call potassium dichromate 6.
okay.
But now, in that process,
Mm.
it doesn't actually, you don't feature in the potassium, the manganate. The only thing that normally can be featured is normally the oxygen, actually. But now it is not in this group. Ama haiko hii class, iko form 4, which tutaongelea hapo. Normally form something like this, huh? You'll have something like that one, which is normally called the carboxylic group, which starts attacking to guze side. Is normally inaandikwanga hivi, a very easy term. And kama hujachora hivyo inakuwa imeandikwa hivi COOH hivyo, but ukiichora inachorwa hivi, where you have now it is connected to another R. R is normally the alkyl group. I know you know the alkyl group. Alkanes ukitoa ukiminus hydrogen moja inakuwa alkyl
Group.
So to which group of hydrocarbons does the substance 1 belong? They're asking you this one. It belong to which group?
Alkyl.
Alkynes. So give two reagents that can be used to prepare the substance. Name one above. So you know the substance. What is used to prepare ethyne?
Ethanol.
Water? No. Ethyne is this one. Yenye tulianzia, sio ndo tulianzia. Mimi nilifunza hii sasa. Umesahau?
Calcium carbide.
Calcium carbide and what?
Calcium
And
carbide.
You cannot say one, eh? You can't
Yes.
say one. You can't say one.
Calcium carbide.
Na mimi nimesema saa hii tu.
Ethanol.
Ethanol, no. No, the first one is okay. But there's something I'm looking for. Nyinyi mnataka kulala. I'm not continuing from there.
Teacher, wait kidogo tu. Teacher, it is calcium carbide and water.
Yeah, si mimi nilisema maji, water and na watu sasa Abdi akaniambia calcium carbide, nikamwambia na nini, na hakusema yenye nimesema.
Water.
Yes, calcium carbide and water. Preparation. That is why nilisema preparation is very important. Now I want you to check the two diagrams, the two charts that you have done. Both zimeleta nini? Preparation of one of them. So lazima ukuwe na idea of the preparation. I hope that one is okay.
Kwa hivyo teacher, tunafaa
Yes.
tuandike hizo mbili.
Nini yo? Yeah. They have said give two reagents. They have not said
Okay.
give a reagent. That is the only issue. Give reagents. So state of physical properties of the substance is physical properties, colorless. You can say it is insoluble in water because it is collected over water. So, no. Physical properties. You see now the problem that comes in is if you forget the things, two physical properties, not chemical properties. Hizi zenye ziko hapa ni chemical properties. So they assume that because tumekupea chemical properties, give us maybe a few. two physical properties. So number one imesema colorless gas. You can say the odor, the smell. You
Yes.
can talk about the solubility. You can talk about the density. You can talk about the melting point, the boiling point. Lakini let us talk about those things that are very easy. For example, I would have gone with the smell and the color. Hivyo, because they have said two. Usiongeze vitu mingi. Give the names of the processes. Step 1 and step 2. Si tumeshapeana hizo. Step 1, hydrogenation. Step 2, halogenation. Is it halogenation or hydrohalogenation? It is halogenation, yeah? Write the equation how substance A is formed. That one is hydrohalogenation, you can write. So unless there is a query, you see now I didn't do, there's something I have not done, but there's no problem. The first thing that we will do to Pitia, I've given you some questions, yeah? I've shared the questions. I still add a few. Nitaongezea kidogo ingine. Let me add a few. Alafu kwa hizo few, when we meet, we can discuss. I don't know, do you have to discuss everything? Do we? So that I don't want to continue. I know people are tired. It has been a long. Kwanza ikiwa holidays, juu mbona watu wanachoka. Do you have a query?
Yes, mwalimu, rudisha kidogo ile ya saa ile flowchart ya saa ile kidogo.
You want the flowchart? Yeah, I think I can do that. No, I was just
Ile
giving out. Yenye nimefanya saa hii. Okay. Do you have a question from that area?
Yes.
No, I've shared this book to the group.
Yes, this one.
Yes, this one.
Zote?
Yes,
Sasa step 2 umesema ni halogenation
yes, it is halogenation. You are counting the
Na hii
number of
ingine-
hydrogens on the other side and the unajua kitu yenye mujakubali ni kuhesabu kwanza. Let me
hiyo
show you
kuhesabu
something up.
unahesabu nini ya sasa kwa hydrogen ama?
Unaona hii hydrogen ni
hydrogen-
ngapi? Si ni 1. Na hapa imebaki ngapi?
1
Haya, hii iko na ngapi?
1
Na hii?
1
So nini imeongezwa hapo?
ni bromine.
Hizi mbili. So hiyo ni nini? Halogen.
Halogen.
So hiyo process inaitwa aje?
Halogenation.
Exactly. Hapa
Na hii ingine hii ambayo iko na bromine ine.
this one, I'm saying it is the same thing. What only has happened is, unakumbuka tukisema, I don't think you were in. Nikisema kuna step 1, alafu kuna step 2. I think the others were in. Anybody who have an idea of the process? This one is halogenation, but what they have done here is they have done 2 bromines. Hii wamefanya bromine moja.
Lakini process all of them are halogenation.
Yes, the process is halogenation. That is why
Sasa hiyo ingine-
they didn't put
Yes.
as step 1, step 2, step 3. Waliweka tu hii moja. They are asking for one name. Actually, this one also is step 2. But now with more molecules or with more moles.
Na hiyo ya HCl sasa ni hydrogen halogenation.
Yes, hivyo sasa.
What about step 4?
Step 4 tulisema ni polymerization. Formation of a polymer.
lakini kuna mahali ingine waweka hydrogenation alafu tena tuseme kama ni chlorine ama bromine wanaweka tena mbili, hiyo itakuwaje sasa?
For example, waweke iko mbili hivi.
Tuseme wakidraw kama saa hii ya bromine alafu unaweza kuta labda hiyo hydrogen halogenation sasa iko na chlorine mbili, bado tu ni halogenation ama ni
Hivi,
halogenation?
let me do it hivi. Iko na mbili hivyo.
Alafu tuseme wakidraw kwa hiyo ya sasa
Obviously chlorine zitakuwa mbili na hydrogen zitakuwa mbili extra.
alafu yote itakuwa tu hydrohalogenation ama
Yote ni hydrohalogenation. It's the same thing.
na sasa tofauti nini? Kama hii iko na bromine mbili na hiyo tena iko na chlorine mbili na yote iko na but iko
You
na
know,
different
there is a
name.
difference actually. There is a difference between hydrohalogenation na halogenation. Itakuwa tofauti. You remember tukifanya, si kuna kitu tulifanya Abdi yenye tulisema bromine moja hapa. Nakumbuka yenye ulisema bromine moja na bromine ingine ni mbili. So kuna pale bromine ilikuwa moja na kwanza ingine ilikuwa bromine ilikuwa mbili.
Yes. Sasa mimi
So
nilikuwa nadhani kama ni
hii yenye
mbili.
iko na mbili
Eh,
hii sasa utaita aje yenye iko na bromine mbili? I think I should go to that question.
halogenation.
Na yenye iko na bromine moja?
Hydrogen halogenation.
Yes, you have the answer. Why are you asking me the answer again?
Lakini ama hiyo ni bromine peke yake ndio inafanya. Chlorine ikikuwa mbili haiangaliwi because
How can chlorine be two? Let me go to that question. Unless somebody else is understanding the question that he is asking, so that we can help each other. I'm going to that question very quickly. Na wewe unasema nini sasa? What you are saying is this. Nitoe hii ikuwe chlorine. Si ndio itakuwa tu bado the same thing. Hii ni kama tu kuweka chlorine mbili. So it is no longer this. So
sasa
you are
process
saying it
bado
could
ni
not be. So hii ni nini sasa? What is this process called?
halogenation.
Yes. So what is your worry now? Your question now is, because it is called halogenation actually.
Mimi nilikuwa nataka
Yeah.
kama ni halogenation ikuwe na tuseme mfano tu chlorine ama tu bromine.
Si ndio hii iko sawa?
Yes, alafu
Si iko na
kama ni
mbili.
hydrogen hii iko sawa sasa, lakini nasema
Mm.
alafu nilikuwa nataka tena kama ni hydrogen halogenation ikuwe na only one chlorine ama one bromine.
Either way it is okay. Kama saa hii iko CH3, CH2, Br. Ama kama hii hakuna ikuwe Cl. Hii pia ni hydrogen halogenation, hii ni hydrogen halogenation.
Lakini kuna mahali ingine
Which
iko
is
kitao nimeona iko na ni hydrogen halogenation lakini iko na two bromine ama two
now
chlorine.
I need to see that one. If I see that one I will understand.
Kwa hiyo kitao tu ya KLB.
Yes, I need to see that. Like you can screenshot that place alafu unitumie and then I can discuss it with you because I know it is possible. It is possible, but you screenshot alafu unitumie.
Sawa, okay.
Yes. So unless there's a query? Iko swali kweli?
No,
Ama tulale tukutane Monday.
Thank you.
yes.
Yeah, okay. Thank you very much. Thank you for attending. We still have that small kapat. Like inataka tu 10 minutes, maximum of 20. Ile tu niwaonyeshe how we test those things in the lab. Lakini nimefunza. I'm saying tunapitia tu turudie because I'm very sure itakuwa kwa exam. Your KCSE that itakuwa haiwezi kosa. And I don't want to be held accountable. and I should have said. So you have a good night. Have a good night. We meet on that day. Hopefully I'll be
Good
in.
night.
Oh,
If not, madam will continue.
it's a Monday.
Okay.
Why? On Saturday you're
Yes.
not there. You're not there on
Uh,
Saturday.
no, this class is actually supposed to be there on Saturday.
Yes.
This class here, Leo, is supposed to go Leo. You know, I'm not supposed to be in today.
Okay.
You should be having Kiswahili or something. I don't know.
Mm.
Yes. So I
Teacher,
was stepping in for somebody. Yes.
hiyo tumesema unataka kutufunza ni hiyo test for unsaturated.
Yes, just for
Saturation.
saturation. So I'm saying, yeah, it needs only 10-20 minutes because it's something that how we do it in the lab actually. Unaweka nini, unafanya aje, hivyo.
So tutafanya kwa practical.
No, now we can't
Right.
do. I'll just do it in theory, but when you have a practical, you can do it in practical sessions.
Yes.
Okay, so we should do that one.
Yeah, we'll start with that one when we meet next, and then we go to something else.
Okay.
Sawa.
Okay. You
Have
have
a
a
good
good
night.
night. Okay,
You
bye-bye.
too. Thank you.